All right, guys, so as we're getting into the swing of things and getting more used to this, we're going to try to shorten the lengths of the videos, but that's going to take more work on your guys' part. So you are going to make sure that you are taking notes as you go through. That's going to be very beneficial so you can look through your notes as you do the Ed Puzzle practice problems and you can mimic the examples that I show you. If you do not understand something, rewind and keep rewinding until it does make sense to you. So this first section that we're going to look at this week involves the midpoint and distance formula. We talked a bit about distance last week when we talked about congruent segments. So we looked at a segment and we tried to determine if it was congruent by counting the units to determine its length. The length is a distance. Now this was relatively easy because we were looking at horizontal and vertical lines, so we would know that AB was 4 units. What we're going to be looking at this week is diagonals and being able to tell the distance between 2 points. Our first example is a word problem. So your school is 4 miles east and 1 mile south of your apartment. The recycling center is 2 miles east and 3 miles north of your apartment. And they want to know the distance between the two coordinates. So this is where the distance formula is going to come in. So I'm going to label the school as my first coordinate, x1, y1. The ones simply are subscripts. They don't have anything to do with multiplying or squaring or whatnot. And then the recycling place is x2, y2. And we're going to fill that in. We're going to substitute into our distance formula. So my x2 value is 2. Subtract my x1 value of 4, and that quantity is squared, plus my y2 value of 3, subtract my y1 value of -1. Order of operations says parentheses comes first. 2 minus 4 is -2. 3 minus -1, so we're going to add that to get 4 squared. -2 squared, -2 times -2 is 4. 4 squared, 4 times 4 is 16. And finally, we get the square root of 20, which I know doesn't mean much to most of you. So I plug that into my calculator, and it is an irrational number, so it goes on and on and on. But I rounded it to 4.47 units. So that is the diagonal distance between the recycling center and the school. The next topic that we're going to talk about is the midpoint. All right, so the midpoint is in the middle of a segment. So if I have a segment that is 1, 2, 3, 4 units long, the midpoint's exactly what you would think. It's in the middle. So it's 2 units from the top, 2 units from the bottom. It would be nice and easy if everything was horizontal and vertical, but of course we're going to be looking at diagonal lines. So we have 2 endpoints, and I'm just going to draw a quick sketch. So we have an endpoint of 1, -3, and 4, 2. And we want to find the exact location of the point in the middle. So our midpoint formula is kind of like finding the average. I'm going to take my x values, so my x1 and my x2, and add them together and divide by 2 according to the formula. Then I'm going to take my y values, so my y1 and y2, add them together and divide by 2. So my midpoint x value is 1 plus 4, which is 5, divided by 2, or 2.5. My midpoint y value is -3 plus 2, which is -1/2, or half. So my midpoint is 2.5 and then down a half. And that is the exact middle of our segment. Example 3 is a little bit different because they give you the midpoint. They're telling you the midpoint is 2, 1. The end point is 1, 4. So if I do a quick sketch again, this is my end point. This time, though, 2, 1 is my midpoint. So I'm going to have some other endpoint that is equal distance away from J, but in the opposite direction. So I'm still going to use my same exact formulas. It's just that now I'm given different information. All right, so my x1 value is 1. I'm going to plug that in. My x2 value is unknown. So I'm going to represent that with an unknown number of x, a variable. My midpoint, I know that. My midpoint value is 2, and of course 1 plus x was divided by 2. So that is my initial setup. I know my y1 value, it is 4. I do not know my y2 value, so I'm going to leave that as y divided by 2. And I know my midpoint value, which is 1. When I solve for this, I want to get rid of the fraction first. So I'm going to multiply both sides by 2. The 2 that is being divided cancels with our 2 that is being multiplied. So I have 1 plus x is equal to 2 times 2 of 4. I subtract 1 from both sides, and my the end point is 3. I repeat my process. I want to get rid of this fraction to start. So I multiply both sides by 2. I'm left with 4 plus y is equal to 2. Subtract 4 from both sides to get negative 2. So my second endpoint is at 3, negative 2. And that midpoint cuts our segment into 2 congruent parts. So as we learn, a midpoint divides a segment into 2 congruent segments. And remember from class, we represent that with a tick mark. When there are lines over top, that represents a segment. So AM is congruent to MB. Segment AM is congruent to segment MB, which means the lengths are equal to one another. So that's how many units they are, like 2 units and 2 units. They have the same value. You can also have a segment bisector. A segment bisector goes through the midpoint. It can be a line, like line CD in this example. It can be a ray that cuts through the midpoint. It can be a point that is the midpoint, or it can be a line segment that cuts through the midpoint. The important part is, no matter what the point, line, ray, plane is, it cuts it into 2 equal parts. It divides our segment into 2 congruent segments. So for example 4, they tell us that M is the midpoint of VW. So therefore we know we have created, or the midpoint has created, 2 equal congruent segments. They then want us to find the length of VM. Well, since there are 2 congruent segments, thanks to the midpoint, that means our 2 expressions are equal to one another. So here we go with algebra again. We set them equal and we solve. and I get an x value of 4. But we're not done, because of course they want us to find a length. So I look up, and my length of VM is represented with 4x minus 1. So I plug in 4, and VM is 15. In this example, it's very similar, but now they want us to know what is the segment bisector. So exactly what is cutting through our midpoint, and that is a line. So our segment bisector is line L. Then from there, we want to find the length of MQ. So since this is a segment bisector, that means it goes through the midpoint. And since it's a midpoint, it divides our segment into 2 congruent segments, which means they are equal to one another. So we're going to set our expressions equal to one another. I'm going to solve algebraically. And x is equal to 2. However, we are not done because we need to find the length of MQ, which is represented by 11 minus 2x. So we have 11 minus 4, which is 7. And that is our final answer. The last thing I want you to be wary of, if there is no tick marks, you are not allowed to assume that they are of equal lengths. So if they don't tell you that B is a midpoint, if they don't show you that B is a midpoint through congruency, then you are not allowed to set the 2 parts equal to each other. You'll have to use the segment addition postulate to solve. So AB's length is 5, BC is 2x plus 6, and AC is x plus 10. Solve algebraically once again. Now, you might be thinking, Ms. Reschke, you taught us you're not allowed to have negatives. All right, now just because x is negative doesn't mean that your lengths are going to be negative, since distances can't be negative. So they want us to find AC, which is represented by x plus 10, or negative 1 plus 10, which is 9. So yay, AC is positive. And they want us to find BC, which is represented by 2 times x plus 6, which is 4. So BC is also positive. So just because your answer is negative doesn't mean your lengths are going to be negative.